So I've been bumped up to speak first. So my name is Gaurav Agarwal. I'm going to be talking about Go concurrency constructs. It's a beginner level talk. So first about me, I'm a lead technical consultant at Tarka Labs. I've been working with Go for about 1 year about now. So I started with Go actually in 2014 at BrowserStack when we were testing the limits of UDP packets. We are sending about 1 million UDP packets. It was just simulating network requests. So I've been an expert worker, independent consultant. I've been involved in the Chennai Go community for the past 6 months. I helped in organizing the Chennai Go meetup. You can look us up in meetup. We have regular meetups every like second Saturday of the month. So please do join if you're interested in Go. Alright, so today's agenda for this talk is very simple. I'm going to be walking you through a simple scraper code. Then I'll be making the scraper concrete using Go routines, then sync them up using mutexes and channels. So perhaps let's get started. Right. So this is a simple scraper. So for people who are already familiar with Python, you would know beautiful soup perhaps. So Go has something called soup, which is Go's version of beautiful soup. Here I'm scraping content from Amazon's sorry about that. Amazon site, basically a TV listing page. I'm on I'm on Amazon TVs and I was looking to make a JSON API out of all the all the different kinds of products in at Amazon. So all the TVs are listed. So we have about 24. So let me just run this code while I talk about it. I'm just adding a pretty formatter to the code. So the code consists of product. It has name like so. If you're unfamiliar with Go syntax, it's not that difficult. We have structs. Structs are familiar to are kind of like classes but without methods. You have name, link, image, and price on a product. A product also contains reviews. It's an array of reviews. Reviews contain the name of the reviewer, the rating, and the content. Rest of the code is basically parsing each review and getting the name, rating, and content from it. On product, I get the reviews by visiting the products page and running the past reviews on it. And on the main function, I visit the main listing page and get and parse all the products. So the output looks currently something like this. So for each page parse, I have the name, link, image, price, and the set of reviews which are there on the product listing page. Straightforward, fair enough, awesome. Uh, so so I've also added timing output to it. Basically a pattern formatted JSON. So it says it took about 49 seconds and to fetch about 24 products, right? Now, this is how I'm doing the getting the timing of it. All right, moving on. So enter Go routines. Do we want to make this faster? So 49 seconds for getting about 24 product results is not really ideal, right? Go has something called Go routines, which are lightweight threads. They are user space threads, which the Go scheduler maps the kernel space threads. So the Go routine, you can pick up Go routine as a concretely running function or method, which runs independently from other functions or methods. Go routines have their own stack and all that. Though I'm not going to go deeper into all of that. I'm just so this is still targeted at beginner. It's going to Right. So let's make it concrete. Let's make our code concrete. So Go provides a keyword called Go, and pretty much that's all you have to do to make your code concrete. Is this visible by the uh, too much? Back to the thing. All right. Let's look at the output or how long it takes to run. Right. So I have my completely running code, and oops, seems like there's no output. I just made it concrete. So thing is, there's no synchronization mechanisms between all the Go routines. So for each of the results which I'm getting, I'm creating a new Go routine. So about 24 Go routines are created, but there's no way of saying that hey, we are all completed, and now you can you can print out the timings and exit the application, exit the program basically. But that's not happening. So probably let's try and add some waiting mechanism. All right. So Go standard library has something called wait group to do this synchronization. So wait groups are so whenever I create a new Go routine, I call the add method on the wait group to say that hey, I'm creating a new Go routine. When all my Go and I wait in my main function until all my Go routines are completed. But how do I say that my Go routine's execution is completed, right? So you have So I'm passing my wait group inside my Go routine. So my past product method function, sorry, and I'm running through. And once my encoding is done, I'll be marking this Go routine. I'll be marking this Go routine as done. Straightforward. So let's look at the output. Hopefully, in yeah, everything came out together. So it took about 4 seconds now. So from 49 seconds, it took about 4.9 seconds, so about 10 cross reduction in time. I thought it was worthy of it. And really, not much changes actually. In terms of code changes, I had minimum. I just added the Go keyword and added the wait group to synchronize between them. Straightforward. All right. Moving on. Now, if you look carefully at the output of my of the function of the program, it actually produces a JSON stream. So for each of the product, it just spits out the product immediately. It does not wait. It does not concatenate them all into an array to print them out, right? So probably let's do something like that, right? Right. So I want to do something like this, where I have products. So Go has a different syntax. In most of the languages, you have the type defined first, and then you have the variable name. In Go, you have the variable name followed by the type information. So I'm creating an array of products. Inside my past products, when my product is ready, I want to insert into my products array, something like this. So no JSON encoding over here, but when all the wait is done, I want to encode out the products. So pretty much we should get the same output, except now it should be inside an array. Right? So all of the JSON is inside an array. All of the products are in a single array. Okay, so there's one thing though. The way I'm accessing or building the product is calling some weird behavior. Let's look at that. Okay. So I've added a race condition, race flag onto my run command. So Go provides this race flag on all the build tools, on all its toolchain, across all its toolchain, and it says that hey, I have a race condition inside my Go routine somewhere, in my code somewhere. It says that hey, you're probably having a race condition in line number 25. Oh, I just started appending products. Because the reading and writing theoretically can happen at the same time, and I could have a race condition where my products would get overwritten with the new upcoming product. So I'll lose some products from my in my products array. How do I avoid that, right? So Go has something called yeah, controlling shared access using mutexes. Let me write a simple mutex. So mutex is a locking mechanism. Probably you're familiar with it from your operating system class, or probably from your microprocessor class. So it allows me to define that hey, I'm about to do something dangerous in my Go routine, and I want to ensure that the other Go routines are not able to access the code at the same time. So I just provide a lock on that, and once my mutation is done, I unlock it. I think I forgot to pass in the mutex. Right. So race condition is still on. Uh, Move databases. Looks good. Looks fine. Right. Let's probably look at the amount of changes I've had. So I've added a product array. Uh, I'm passing sync weight group and mutex, locking, unlocking, marking the synchronization as marking my coroutine as done, and using weight groups, mutexes, and all that. Seems kind of messy, right? Wouldn't it be nice to have something much more simple, a simpler construct to do all these concurrency and to synchronize between all these different go routines? I'm just throwing away all the code. So no changes. Back to the beginning. I'll just have the go routine, but I'm gonna have something called channels. Uh, so a product channel and initializing it to have a product. So a channel is like a queue which is synchronized across different coroutines. It's thread safe. It allows me to write code such as procedures. So instead of including over here, my chunk coming here, chunk product, and then my product is ready. So I can write into a channel using the arrow syntax, something like this, and then I can also read from it using something like this. I forgot to pass my channel. Let me just pass my channel. No pointers, I think. The previous code had pointers, no pointers. So we are back to having the array output, right? No race conditions, no no manually synchronizing or my code, but it all runs, it all works. So, but let me just add this as well to complete the demo. String and so now I should have the same array output, right? Yeah. It takes about the same time. No memory, no optimization, but it's just that the code looks much simpler, much better. So I have the channel passed into my pass product, and I instead of encoding right away, I'm just writing into my channel when the processing is done. And in my main function, I loop over, I read as many times as I'm creating the go routines from the channel, right? So one property about channels is that it's blocking in nature. So you have unbuffered channel. That's the type of channel using. So basically, an unbuffered channel has a queue size of one. So that means that I can write into the channel until one freely, and after that, the write could block if the channel is full. So until someone has read from the channel, it's going to block. The reader is going to block if the channel is full, and the writer is going to block if my channel is empty. Right? So that's the property of chunks. That's the synchronization mechanism which Go provides out of the box. So both channels and Go routines come from something called the CSP paper. So no, not that. Yeah, communicating sequential process. So it's same as the one which we have in Erlang. So if you are familiar with Erlang's concurrency model, it's quite simple. It's just that the abstractions are at a different level. So in Erlang Elixir, you'll be sending it into a process ID, and in Go, you'll be sending it into a channel, writing into the channel. So that's pretty much what I had to talk about. So the references for this talk were basically Ropike's Go concurrency pattern. So it's a pretty cool talk. It's a 2012 talk given in Google I/O. So he talks about how to build a concurrent, scalable, fault tolerant search 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 API in like 5-10 minutes. Wagner Mudumbai is thinking in Go. He talks about different patterns of accessing Go routines, of working with channels and Go routines. Tour of Go provides the concurrency. It has concurrency examples. Go by example is my go-to for looking up code, which I should understand, but I don't right now. That's it. Good. Questions?
This works on a similar type of data structure, right? It's something like you have a product on which you are
Right.
a bunch of products and you are doing a parallel study.
Right.
And you are bringing them together to join and then you are producing it.
Yes.
And the join, you want to ensure that the channel actually implements your
So
like
Go is statically typed. You have your channel needs to have a type,
yeah,
which it gets. But having said that, you could write code like this, where you're defining interface, and you can accept pretty much any type.
that's what.
Though I would not recommend writing such code because
Yeah, I got you.
your compiler cannot catch errors. Like you'll be producing runtime errors. Um, Having said that, one more thing which I forgot to add was the select. So Go provides a select channel which allows you to communicate with or read from multiple different channels at the same time. So your channels could be of different data types. Like for example, how much time do I have?
Yeah.
10 minutes. Okay. All right. I'm gonna do. Let me just write the number of reviews I've got. Right. Can't really do it inside the same routine because it would serve the purpose because it would block on in RCH. I don't have a elaborate example to show you. I'll probably show you something from the net. Yeah. So I'm pulling this from Go by example. So you have two chunks created. One is a string, one is a boolean, and I'm saying that I'll be reading from. I'm writing a select case to say that I'll be reading from messages, which is of type string, or I'll run the default. The other one is I'm running a message hide, and I'm sending to the channel, or else I'll be saying that there's no message sent. So probably just I'll just copy paste this code and see what happens. I just copy all the strings as well. My Go code is formatted. Okay. Before I begin, could you guess the output of this function, of this program? So I have a select which is blocking on messages on the first message to be received, and in the other select I'm writing a message into messages, and in the third
Receive the message.
receive message hi.
No, no message received.
I actually don't know what's gonna happen.
Oh, it's completely.
So it says no message received, no message sent, no activity. That's because of the nature of select. It's non-blocking. So whatever code I write in a select block, it won't block. It won't block my current piece of code. Like my main function is not going to block on the first line of code, which is case messages. It's just going to hey, see, there's a default message. I should probably just go there. But what happens if I kind of for loop? So my entire code is inside a for loop. I'm saying, hey, I'm going to sell indefinitely. Yeah, it's still unblocked. It's still not blocking actually.
So the
I can
the high doesn't get sent into the channel itself.
the the problem is there's a default condition. So it basically looks for if there's a message on the hide. If there's a reader on the hide. Okay, so
So there has to be a reader for it to be successful.
exactly.
For it to
So the
successfully
first select basically quits because the first reader does not has a default case. So it just skips to the default case and executes that. The second one, it has a message hide, and now it's blocking. So that select would be blocking. I think it won't even print anything right now.
Pretty much like Unix pipes or something.
Pretty much. Oh, that's because I also have this one. I have to remove all defaults. I need at least one default. Hmm.
So technically, it will be, the probability of catching a case where there is a reader reading on it at the moment when you are attempting to write is
Yeah,
very
it's
less.
very slim actually.
So I don't think we can. I mean, I don't. Based on what I understand, forcing it might.
Yeah, it would. It would actually. I would actually need a blocking.
Blocking thing for it to.
So awesome. Any other questions?
What's the race condition?
Oh, the race condition which was happening was basically so so I had so what I was doing was something like so this is a global variable. It's accessible both by all my go routines as well as my main function. So there was no scoping on it, and I was writing into my products, reading and writing into my products in the same line. Theoretically, what this means, though practically it won't happen that my two go routines happen to read and write at the same time, but it pretty much opens my code up for race conditions where two go routines or multiple go routines could read and write into products at the same time. And yeah, that's what the race condition was about. So the code is available on low concurrency constructs. The slides are up on lowconcurrency.png. It's a long domain name, I guess. That's pretty much it. Right.
So guys, we'll take a 10 minutes break and we'll join for the next talk. Thank you.